So I am Jean-Pierre LORRÉ. I am in charge of the research activities of l'INAGORA, and I am going to explain you the work we carried out to develop the Lucie-7B models. So a bit of context around why we are developing such technology. So just a few words about l'INAGORA. L'INAGORA is a historical leader in open source in France. It's more than 25 years old, the company with 160 people. We are doing from the very beginning, we are involved in open source. Obviously, we are not doing, we have not been doing artificial intelligence from the very beginning, but we are working on those topics related to natural language processing and speech recognition since around 8 years, I would say. And why we are involved in such work is mainly because we are developing open source technologies called Linto, and Linto is a set of software components that allow to transcribe and then to extract knowledge from speech transcriptions. Doing that, we have been involved in the AI world, and around 1.5 years ago, we decided to initiate the OpenLLM community, which is now quite a large one, organized around many collaborative components. And as you saw here, the community is more or less informal. It's grouped together individual, but also organizations that are concerned by large language models and open source. And now, why was our motivations behind the development of the Lucie model? At first, the first motivation was around cultural representation. As has been told previously, most of the current AI models available nowadays are coming from the US, a small part, but from China, and a very, very small part from Europe. And we were very involved and interest in the representation of the French in such models. And when you have a look to, for example, to the Llama dataset that has been used to train the Llama model, you can see that you have a very, very, very small amount of European language involved, even for Llama 3, which is pre-trained on only 5% of non-English data. And as you may know, even if those models are quite fluent in French, for example, they are not involving all the cultural assets that a language embed. because a language embeds the history, it embeds the politics, the art, the religion, and all the social practices of a community of people living together since years. Even cooking is for some communities. The second modification is because of the DNA of Linagora, is to foster a truly open source artificial intelligence. So it has already been presented here last year by OSI people, but just a few words to remind you what is the nowadays definition of an open source AI. So it's organized, this definition is organized around the four freedom, which is to use, study, and modify and share artifacts that are then able to be said as open source. So when you deal with AI assets, this means that you have to provide your models under the weights of your models under a license that allow an unrestricted usage. So you have to provide those model weights. That's, for example, that what did such organization as Meta for Llama or Mistral. But taking the example of Llama, the license has some restrictions. So according to this definition, Llama is not an open source AI. You have to provide open code, so the code you use to train your model and to manage the data. And at least, and the last point, which is not the least one, is regarding data. And according to the definition, you have to provide the complete list of data sets used to train the system and the actual data sets when allowed. So this was a point that has been heavily discussed around the open source community, but this definition seems to be quite a good equilibrium. So, you can, according to this definition, you can see that obviously Mistral is not open source because nobody knows about the data they use to train the model. And the last motivation was around the development of small language models. Why such choice? Because at first there are many papers and many that illustrate that small specialized models can achieve very good performance comparable to general purpose one. The second reason is that smaller models are more resource efficient, and this is a very important aspect when we speak about AI models. And the last one is the trend nowadays in the community to build applications from specialized models that are grouped together, even if agent-based architecture or some others framework. And we have been selected by BPI and France 2030 initiative for the OpenLLM-France research and development project. It's a 2-year project, and the aim of this project is to develop multimodals, voice and text, large language models, and dedicated to the education domains. This project started on September 24. And we have a consortium with multiple actors coming both from the academic world and the industrial world. So now some details about the model itself, and starting by the training dataset. So this the dataset, as said before, we wanted to focus on French language. So we combine a large amount of French textual data. As you can see on these figures, you have more than 30% of French. Then we have English and data, and German, Spanish, Italian, and a bit of software code also, and textual data, and so on. Most of the data are web data, 70%, but we also have newspaper, technical books, and so on. This is the data set, which is available on Hugging Face. And then it's around 2.3 billion tokens. And then we took this data set to build the data mix that we use for the training. And for the training, we choose to upsample a bit the English part in order to have equality between the French and the English. And so you have in this slide the precise figures. The size of the data set is around a bit more than 3 trillion tokens. What about the architecture? For the model architecture, because it was our first model from scratch, we decided not to innovate on this architecture. So we choose a classical transformer architecture, more or less the same that the architecture of Llama 3. So you have the figure here. I am not going too much into details. So we have more or less 6.7 billion parameters. That's why we call it Lucie-7B. We developed our own tokenizer. The tokenizer part is quite an important one. When you deal not only with English language, but also with other languages, and you want to have a very compact model. So you have to design your tokenizer and to train it. And then we run the training pipeline, which is mostly organized around 3 phases. The main pre-training phase, where the models saw the 3.1 tokens. And then we did a phase of context extension in order to be able to have larger context. So the context size is 32K tokens. And a small annealing phase. During this phase, you show the models very high quality data in order to improve the performance. In particular, we wanted to focus on mathematical, because during the training, we discovered that our models were not so good in mathematical. But we are not so happy with this last aspect. Regarding the training, we use the Jean-Pierre facilities provided by Agency and Idris, the CNRS body in charge of managing this supercomputer. We used we have the opportunity to use the new H100 GPU provided by Jean-Pierre. So we used 512 H100 for about 500,000 GPU hours. And we use training code, which is a fork of Megatron DeepSpeed. And then we did some evaluation. In fact, we did those evaluations during the training, as you may think, in order for us to be sure that we are not in a bad way. And the result shows that we as expected, we have quite good in French. We have relatively good results in European language, German, Spanish, and Italian. But we were not at the level of Llama 3, for example, on English, clearly. But obviously, it is more or less reasonable, since Llama 3 saw 15 billion tokens regarding our 3 billion tokens. And then we have the foundation models that we need to fine-tune in order to be for the models to be able to do a task. And then we provide a first instructions tuning where we obtain some interesting results, as you can see on those figures. All those figures and data and so on are available on the archive paper and also on the Hugging Face model cards. which are there. So we, as you can see, and as we claim, we are fully compliant with the open source initiative definitions. And our current work focus at first, because we, as you may have heard, perhaps we had some issue when we open the model. So we are deeply involved in model alignment nowadays, because the model is targeting the education domain. And we are also working on different topics in order to improve the performance, mostly around its capacity to reason and to manage mathematical issue. And we are going to launch new development and new models, which are planned by the end of this year. Thank you.